Okay, let's do a brief recap of operations with functions. Okay, so when it says f plus g of x, the word right here is of. Okay, they both have to have variable x. Okay, it's not multiply. You can do a variety of operations. This one wants us to add these two functions. So the most important thing is you write down f plus g of x. Okay, I'm going to use a red pen right here, and I'm going to say start labeling your work. Okay, what are you doing in each of these lines? Please write that down. I am going to take the first function, which happens to be a rational function. I'm going to add it to the second one. Okay, and how do you add fractions? You have to make a common denominator. Okay, so I'm going to multiply the second one here by the quantity x plus 5 over x plus 5. Let's start using parentheses to show how the entire quantities here have to be multiplied together. And then same thing over here. I'm going to give him the denominator x minus 2. You must multiply top and bottom, okay, so that it's multiplying by a factor of 1, which does not change the expression. Okay, second line, please use an equal sign. I am not going to multiply the denominators together. I'm going to leave them separate. I will leave them in factored form so that my domain later on is easy. Okay, so I never multiply the common denominators. I am going to have to multiply these numerators together. Okay, some of us were forgetting to put the plus sign there. Okay, and then ended up doing too much multiplication. I'm going to multiply these two binomials and get a trinomial, and then multiply these two numerators there. Firsts, outers and inners, minus 6x plus 8. Okay, foiling out these two, we get x squared plus 2x minus 15. Okay, the reason we have to FOIL them out is so we can add all of the like terms. If this operation was a minus, you'd have to distribute a negative sign in right there. So be very careful with that sign. Again, parentheses might save you. Final answer for f plus g of x. Okay, make sure you label your answer. The like terms make 2x squared minus 4x minus 7 over x minus 2 and x plus 5. Okay, now how do you state the domain for something like this? Okay, remember, whenever you're doing operations, I think we wrote this sentence down one time, right? We look in the beginning. Okay, make sure you look in the middle, and then of course, make sure you look in the end. You have to look everywhere for domain. Okay, so sometimes in the beginning, we look at f and g and write the domains down right away. Okay, so I'm noticing that we cannot use negative 5. We cannot use a 2. Okay, in the work right here, 2 and negative 5, I've already considered them. The denominator right here is common. I've already considered them. Right here, I've already got it. So I think it's very clear that the domain for this new problem, okay, for the sum of the two fractions, is all real numbers except, okay, it's very important that you say all other numbers are allowed, except I cannot use a negative 5 or a 2. Remember, when you're doing divide, okay, and sometimes you flip a fraction and you add somebody to a denominator, you add a restriction. Okay, this is the sum of two fractions, and this is the domain for this final answer. Okay, I'm using a new teal pencil right here. Isn't that nice? My other one broke.